let's talk computers for a second. I'm going to be reading something from this computational physics book. Chapter 1, read something kind of interesting. I figured I'd share it. This is literally the first page in the book. So the first working digital computers in the modern sense of the word appeared in the 1940s. And almost from the moment they were switched on, they were used to solve physics problems. Side note, I think the internet was also created originally for physicists to send information regarding problems to each other, right, from like far distances away, right? So somebody check that, right, and let me know if I think that's correct, that like originally the proposed idea for the internet, right? The first computer in the United States, the ENIAC, 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 a 30-ton room-filling monster containing 17,000 vacuum tubes and over 1,000 relays. This was completed in 1946, and during its nearly 10-year lifetime, it performed an extraordinary range of calculations, nuclear physics, statistical physics, condensed matter, and other areas. Of course, the ENIAC was succeeded by other faster machines, and later by the invention of the transistor and the microprocessor, which led eventually to the cheap computing power that has transformed almost every aspect of life today. Physics has particularly benefited from the widespread availability of computers, which have played a role in virtually every major physics discovery of recent years. What the rest of this, like, page and a half kind of goes to say is physics and math, too, they're at such a degree right now that, no pun, that we almost need computers to solve some of the stuff that we have, right? It's just, it would take so long for pen and paper. The way that we've implemented our math and physics using computers, it's able to solve a lot of stuff a lot faster than we can, right? Also, if you set up things appropriately, it's prone to less error, right? Because when you have to write out some of these problems, trust me, I've had to do this, you are very prone to mistakes, right? When you have like a 4-page problem that's trying to get to some sort of answer, right? That gets pretty daunting, and then you have to flip back and forth and you don't know where the heck you went wrong. This also does kind of say that the first couple of years in high school and in college you spend using pen and paper and you kind of go towards some sort of solution for the problem, but that is not necessarily the reality. We rely heavily on computers. A lot of times we'll start the problem on a computer and then rely, use it for the whole process, right? You just might find out, hopefully sooner than later, that you're going to need to implement a computer if you're wanting to tackle some of the bigger problems in physics, math, not just physics either, but like science, right? Like biology, which goes into medicine. And this is why we have some of these computers, these supercomputers, right? Which is kind of cool because a supercomputer now has taken the place of this, this quote, 30-ton room-filling monster, right? That's pretty much what supercomputers are now. But what does it do? Well, that's a talk for another time.